Think math.
Last time we found the area of a single bar. So what about all of them added together? The whole area a histogram covers? Wherever the peak sits, whether the picture is sharp or flat, that number always comes out as the product of the same two things. Write out one bar again. The width is the class width, and the height is that class's frequency. So the area is the class width times that frequency. The first box, the second box, every box has the same form. Only the frequency changes from one to the next. Now add them all. Class width times the first frequency, plus class width times the second, and so on to the end. Laid out like that, something stands out. Every single term is multiplied by the same class width. The only thing that varies is the frequency, so it can be factored out. Pull the shared class width to the front, and what is left inside the bracket is the frequencies, all added up. And the frequencies added up is the total frequency, which is how many pieces of data there are. So the total area is the class width times the total frequency. What that value means is rather nice. Wherever the data bunches, whether there is one peak or two, as long as the class width and the number of people match, the total block is identical. In a histogram, the shape tells you how the block was shared out, not how big the block is. So all we did was factor out a shared multiplier. The class width comes out front, and the frequencies collapse into the total, leaving a product of two numbers. Next time, we turn those bars into points and join them up. The frequency polygon. See you in the next one. A sip of math every day here at Think Math.